So riverboat, anyone having any confusion? Riverboat, or it is fine for everyone, whatever we did in the last class. So tell me whether I have given this question in class or not. Just a second. This question I have given in the class, no? Can anyone confirm? Distance between two moving particles P and Q is A at t equals to 0, and V are be their relative velocity. If U and V be the components of VR along and perpendicular to PQ, then the time when they are going to be nearest to each other we have to find, and what is the nearest time we have to find. Anyone, can you confirm we have done this question in class or not? If not, we are going to do it now. So whenever I take extra class, I'll not be teaching new things. That does not mean that you should not be coming to these extra classes. Just it is VR, okay. I hope you got the question here. Distance between two moving particles at any point of time, or maybe at t equals to 0, is given to us. And the relative velocity of one with respect to another, that is given to us. And how it is given in terms of the components, that it is having a component u and v, where u and v are the components along the line joining them, and along the line perpendicular, along the direction perpendicular to the line joining them. So maybe I'll draw that figure for you. So we have done this question in class or not? Just help me recall. No? Anyone?
No, sir.
Okay, then we'll do it now. So what is the situation given is, this is one particle P, and see in this question, they are talking about the relative velocity of one with respect to the another, correct? So they are forcing us to solve this question not from ground frame, but from the frame of one of them. So we have two particles P and Q at T0. The separation that is between them is given to us as A. Now, what is given is that suppose if I sit in the frame of P, because I am going to sit in P's frame, then what we find that is given, that velocity of Q with respect to P is equal to VR. And this velocity has two components. One component which is along the line joining them. So this velocity has two components. One is U, that is the velocity, which weight is U and V be the components of VR along and perpendicular to PQ. So this is along the line joining them. and V is the component perpendicular to the line joining them. And what all things I have to find? The things that we have to determine are minimum separation and the time when they are going to be at minimum separation. But one thing is nice, that velocity of q with respect to p is constant and it is of magnitude vr. So constant velocity, our life little bit easy, because constant if velocity is no acceleration, the kind of motion the particle will have will be a straight line motion. A straight line motion, quite easy thing to calculate things, no? So now check out, suppose if I sit in the frame of A and I'm observing B, then what we are going to find that B, okay, not B here, I thought A and B. We are sitting in the frame of P and we are observing Q. Then what really it is given that velocity of Q with respect to P has two components. One this black one, which is perpendicular to the line joining them, and it is V. Another one is the one which is along the line joining them. Now, if I say velocity of a particle or a particle moving along x, what it can mean? It can mean it is moving along plus x, or it can also mean moving along minus x. But before I discuss anything further, we have done this thing in class, just I'm making you recall these things. Suppose if I sit in the frame of A and I find that velocity of B with respect to A is constant. And velocity of B with respect to A can be given to us in these two manners. Maybe I'll draw. Just a moment. Suppose if I sit in the frame of A and we have to observe B. And we find that by being in the frame of A, the velocity of B with respect to A is along maybe this red arrow. So that is the velocity of B with respect to A. And that is constant. Okay. This velocity is constant. It means if I sit in the frame of A, I will find B to be moving along this red line, correct? So this is the path of B with respect to A, means whatever path B will be seen having if I observe him from the moving frame of A. That can be one situation. There can be one more situation, maybe like this. So in this situation, we have velocity of B with respect to A directed like this. So when I sit in the frame of A, what really we think? A not moving, man. A fixed, A not moving, and B only moving, but moving with this velocity which is constant. So by being in the frame of A, I will find in this case too, the path seen by A of B will be along this straight line, correct? So tell me in which case of in this two, the separation is increasing, in which case it is decreasing. Can you answer it?
In the first case, the separation is decreasing, and the
Decrease,
second case, it's increasing.
increasing, no? Correct. So for separation to decrease, there must be a component of VBA L in the direction towards A, no? Correct. Now the separation to increase, I will need the component of VBA to be directed away from A. So the velocity of B with respect to A, the one which is along the line joining them, I call it as VPA parallel. Velocity of B with respect to A, along the line joining them, I want it to be towards A, then only I can say the separation R between them will be decreasing. So by looking at how the velocity vector of B with respect to A is I can tell no in which case the separation decreases, in which case separation increases, correct? Now coming to this one. If I tell you the component of the VR or velocity of q with respect to p, the one which is along the line joining them, it can be this way, it can be this way. So which is correct in context of the question, which is correct? The red one is correct or green one is correct? Tell me.
Red one, sir.
Red one, yeah. Because what is u and v are the component of this vector, which is vqp, or which is the relative velocity of q with respect to p. So that vector will be in this direction. Velocity of q with respect to p will be in this direction. In another case, this one, velocity of q with respect to p will be in this direction, correct? So in this case, the separation, if it is this case, then separation between p and q will increase with time. So there's no point in asking that question. Now, if I give you, we have a function which is always increasing, never decreasing, find minima. That's like totally like nonsensical kind of thing, right? So same way here, they are asking us find the time when they are at minimum separation. So separation must decrease with time. Then only such questions, asking such question will be making some sense. So that's what that is something here. They did not told us in what direction the component u is, whether it is towards p or whether it is away from p. So from the context, we understand that it must be towards p. Otherwise, asking such question like finding minimum separation is not going to make any sense. So got the point. Now sometimes you have to read between the lines. Everything will not be told very clearly. Something which is like obvious that for the separation to decrease, the component of the relative velocity of one with respect to another must be towards the point P. So I hope this part is everyone understood, no? If this much you understood, physics over, man. Then after that we'll do some simple maths and we'll get the answer. This is the main thing to understand. All of you understood or not? All of you understood, no?
Yes, sir.
Yes, sir.
Ghazala got it, no? Tasan understood, no? Mehul understood, no, man?
Yes, sir.
Okay, man. Okay, so I'll take a new page. So no issues if you don't copy, but maybe if you copy, it will be nice. But I can tell me when to take a new page. I will take then. Okay, don't copy it now. No problem. Just after the class, you sit down for some time, copy all of it. I'll check in the next class where you have copied also. Okay. Now the job is to solve this question. So for that, I needed some bigger figure to be drawn. So we are sitting in the frame of P and observing Q. And we find Q moving in this direction with speed constant, velocity constant, which is Vr. The velocity of Q with respect to P is of magnitude Vr. Maybe I'll use different color. So velocity of P with respect to Q, velocity of Q with respect to P is directed like that along this red arrow, and it is of magnitude Vr. So what we find Q, so literally what kind of question we are solving, man? So the purpose of this chapter is to make you have that kind of mindset, the one you should have when you are doing things which is observing something from a moving frame. So P really moving from ground frame. But once I sit and observe from P, the thought process goes like that P literally considered to be not moving, fixed, and Q only going to move, and Q is supposed to be moving along this straight line. So Q is seen moving along this green straight line. So at t equals to 0, this is the position of the Q. And it travels along that line and reaches a place. What place? So for that I will drop a perpendicular. So this pink line, pink only, no? Yeah. This pink line is the perpendicular dropped from point P to the straight line on which Q is seen moving. So the foot of the perpendicular, maybe I call it as, what to call, man, suppose A. So what is A? A is the point where B reaches at time T. So that is the position of what B, Q, no? Position of Q at time T equals to T. At this moment, our point Q will be closest to the point P, since the minimum separation between a straight line and a point is the perpendicular separation. So the job here is to find that perpendicular separation that will be the minimum separation. So how to find out this length? For that, it requires some math things. Depending upon what can be easy, that we will do. So maybe suppose if I tell you that, okay, the length of the side PQ in the triangle APQ, okay, maybe I'll name it as something else. So I name it as capital R. So in the triangle PQR, the side PQ I know. In case if I'm able to find this angle, let's call it as alpha. So maybe I can find out no what is PR is, but how to find that angle? Any idea? So what is that angle? The angle made by this red arrow with the line which is QP. Maybe you can think like this also, but no need. But still, if you want, if I ask you, maybe you consider this as our y direction, this is our x direction, just for easy understanding purpose. So what is the velocity, the point Q with respect to P it is having? So let me draw that thing here. So it is having a component along x direction, which is told it is equal to how much V and that green arrow. And it has a component along y direction, which is U. So how to, and this is our vector, which is VR. So totally we can write now what VR vector is. VR vector is Vi cap plus Uj cap. So what is the length of this VR vector is root over V square plus U square. Now I can shift this green arrow parallel to itself. I can draw it here. I hope such things are everyone is comfortable with. So this dotted green arrow will be of same length V. And in that triangle formed by VR, U and V, I have to find this angle alpha. So I hope everyone can find that angle, no? So in that triangle, hypotenuse is of length VR. This length is U and this length is v, and I have to find alpha. So everyone can see we can find alpha, but we'll not be finding it now. There's a reason for that, because I don't need angle basically for solving purpose. We may need sine alpha, we may need cos alpha, we may need tan alpha. So we will find them directly. Okay. So let's solve the other part. The triangle PQR we have. In that triangle PQR, job is to find the length PR. So can you write down sine alpha? No? Sine alpha in this triangle will be PR by PQ. PQ is of length how much? A. PR, I'm calling him as R perpendicular. So what we get, R perpendicular is equal to how much? A sine alpha. No? I hope my voice and my writing things are going simultaneously, because I'm using iPad to write but using phone to talk. Things are going fine, no?
Yes, sir.
Okay. So tell me, from this triangle I can find sine alpha, no? How much is sine alpha? You see, sine alpha is going to be
Sir, here
u.
V and U should be interchanged, no, sir?
I interchange it just a moment. What is given? No, no. U is along the line joining them. V is perpendicular. Correct only. Correct. So it is having V along X and U along Y. I'm calling Q to P direction as Y, and it is moving in that direction. See, from this figure here, which way U is towards P, and which way V I have taken this side, and I took U direction as plus Y, V direction as plus X. Clear, no? So VPQ name is VR. Okay, like who will write VQQ, VQP, VQP? I am writing down him as VR. Okay. So VR has X component V, Y component U, or I don't have to use that. In this triangle I made using VR and his components is a right angle triangle. His height is U, base is V. So what VR is, totally we can find out using Pythagoras also. So that will be V square plus U square. So sine alpha will be U by VR, correct? So what is minimum separation? A into U by VR. So VR given, but if U and V only given, VR must not be given. I can find him out. That guy will be root over V square plus U square. I hope this part is everyone has understood. Good, no?
Yes, sir.
Okay, then now what is the remaining part now is to find the time t. What time t? The time when Q is closest to. So when Q will be reaching the point, so just a moment. So the point Q is moving like this and reaches the point R. So, and with what velocity and speed he is traveling with? Constant. So constant velocity and the speed if someone travels with, how to find the time? So distance he covers to reach R is equal to the length QR. It means I have to find that length QR. To find that length QR, again, I'll be doing the same thing using the triangle PQR. So in the triangle PQR, you see cos alpha will be equal to, I hope everyone has joined from big screen only, no? Or else maybe joining from phone, you cast your phone to TV or something. Don't join from a small screen, man. It will be like the headache to understand. Yes. So cos alpha is going to be how much? Is going to be QR divided by PQ. So PQ is equal to A, so QR is equal to A cos alpha. And what is cos alpha? We can find out from this triangle. So cos alpha will be V by VR. So just we are going to plug it there. So QR is A into V by VR. So literally I'm thinking P fixed, Q only moving. So in time t, it undergoes displacement test. So what you will write? Displacement equals velocity into time. Correct. And with what displacement he is going to undergo? QR. With what velocity he is moving? VR. So T will be equal to QR by the length of the vector VQP, which is VR. So what is QR? AV by VR. So AV by VR divided by VR, what it becomes? AU by VR square. So I can leave it here, but since if VR in case not given, which was not essential to be given, I can find VR. So VR is this much, so VR square will be V square plus U square. It is A into V. Okay, I hope this question is clear to everyone or not. Clear, no? Whatever we have done till next week, maybe till maybe till Friday, that much only will come in the test. Still, we should be completing the related module without before the test. We are not doing things for LN test only. We are doing things for J, you know. Which part you want me to explain? See, the time part, no? Time part, no, Manoj. So you think that we have a point P which is fixed in ground frame only. And point Q is the only moving point. And that moving point is so clear your brain, like it is not a relative motion question. Think like that. Think it is a simple question where a person Q walking in a straight line like this. When this person Q walking in a straight line like this will be closest to the other person who is stationary P, when he will be at the foot of the perpendicular dropped from P to the line on which Q travels with respect to P. You will write that thing. So R perpendicular is the perpendicular drop from P to the line on which Q travels when seen from the frame of P. If whatever I've written, this statement is clear to everyone, no? The statement clear, no?
Yes, sir.
Okay, then. So tell me how long point you will take to reach R. So with what he is traveling with? Constant velocity. I've exchanged the vector V and U. Where I have exchanged the vector V and U? I've not exchanged this vector here, man. This is V. I'm shifting V parallel to itself, drawing him here. So that using this red arrow of U and green arrow of V, I am applying triangle law to find its the resultant, which is VR. Okay, yeah, I have exchanged. Yeah, here I have exchanged. Yeah. Now I see that.
That one, sir.
Yeah,
We
yeah,
have
yeah,
you
yeah.
have to.
Yeah, correct. I got it. This is V, this is U. So answers will come different. So sine alpha will be V by VR. Sine alpha is V by VR. So A V by VR. Here I will get. Now cos alpha will be U by VR. So it will be U here. So we'll be having U here. We'll be having U here. We'll be having U here. I hope it is correct now. Now, how much displacement he undergoes QR. So we found out how much QR is using the triangle PQR. And once we got QR, we write displacement equals velocity into time. Displacement QR with what velocity it travels VR. So time t we can find out. That is what we have done. Manoj understood, no? All of you understood, no?
Yes,
Yes,
sir.
Okay,
sir.
then. Now we'll discuss the module. Any doubt in the module you can ask? Or maybe I will ask you to solve questions. Let's solve question number 8 of exercise 1, I think it is. No, exercise 2, question number 8. So again, this question is regarding how to think by being in a frame, which is a moving frame. You want to try or I should solve it? Maybe try for some moment. Hint is you sit in the frame of that moving cubicle box. You want me to explain this question to you? Mhm. So we have a cubical box which starts moving with an acceleration given, and it is starting to move from the position of rest, but moves with this acceleration. Suppose if I want to solve this question by being in the frame of this box, then I must know the velocity of the particle that we are observing from the frame of this box. To solve kinematics, what we need? Initial velocity, initial position, and acceleration. The same thing, if I am sitting in some frame and observing an object, then what I will need? I will need the initial position of the object with respect to that frame. I will need initial velocity of that object with respect to that frame and the acceleration of that object with respect to that frame, correct? So what to do? Okay, before that, no, I wanted to give this question in class, but I have not given. Maybe we'll try this question first. And it is like question from S.C. Verma solved example. And we'll be solving it by being in different frame, but you will find we are going to get same answer. Easy question only, nothing difficult. this question. So some math thing I'm going to do in this question that should remain in your head. It can be of use. That's why also I'm discussing this question. So we will discuss that also. Maybe you try this one first. And we are going to solve it by being in the ground frame. And maybe we can solve it by being in frame of one of them. So the question is, a police inspector in a jeep is chasing a pickpocket on a straight road. The jeep is going at its maximum speed v, and that is uniform speed. The pickpocket rides on a motorcycle of a waiting friend. When the jeep is at a distance d away, the motorcycle starts the constant acceleration a, so that the pickpocket will be caught if v is more than or equal to 2AD. So you want to try, or I should solve it, but maybe you should try one. Okay. Till you try, I'm drawing figures. So what is given is this is our police jeep. Maybe I call it as maybe who will say police jeep and all. I'll call it as A. And this one I call it as B. So at t equals to 0, the separation between them is D. And what happens after that? The police chief starts moving with a constant velocity, which is V. And this bike guy starts from rest. So his initial velocity 0, but obviously that is not given that which way the acceleration the bike will have. But it is obvious, no? He must be moving away from the police, no, not like he is going to do like, what is that called? What is that called, man? When they go and give themselves to the police, I don't know. I forgot that word. So obviously he must be running away from the police. So the acceleration of B is equal to A, which is constant. So they're telling us prove that the pickpocket or the thief will be caught by the police only when V is more than 280. So what to do? Maybe you will not know what to do in the starting. You just go with the flow. That is, so you consider if they catch up with each other, what will happen? They are going to be at same place after some time. So suppose both of them traveling this way, and after some time, the police jeep and the bike reaches same place, and like police guy going to hit the bike and all. So tell me how much displacement the bike has undergone in time t. So at t equals to 0, our police jeep is here, no? And at t equals to 0, our bike is here, no?
Sir, sir,
Just tell me.
sir, I have a doubt, sir.
Tell me, no, tell me.
Sir,
Tell me.
should we assume that he will be definitely caught first and then
Yeah,
solve for
yeah,
V greater than
yeah,
I?
yeah, yeah, correct, correct, correct. So when I will know so what is the condition under which he will be caught? We will see what happens when he is caught, correct? No, because no other thing we can think of other than this, correct or not? Suppose so
Yes,
they
sir,
are
but
asking us, and they are
uh,
asking us under what circumstance or under what condition they will be caught. So I have to know what happens when they are caught, correct? That's why we are thinking, okay, if
yes, sir.
police jeep
Okay.
catches the bike, then what happens? Once I solve something for that, then only I will know what can be done next. Suddenly, every step will not be revealed to you. Whatever possible from our side, that much we do. Correct? No? So, no. I hope
Yes,
this. So,
yes,
so
sir.
now, in times and at t equals 0, our police guy here, at time t, he reaches here. At t equals to 0, bike here. And time t, bike reaches here. So at in time t, if I ask you how much displacement the bike has undergone, this much, correct? How much the displacement the police has undergone, this much, is it not? Suppose I call displacement of police as SP, or I call him as displacement of police as SA, and maybe I will call displacement of the bike as SB. So if they catch up with each other, so what we are doing right now, we are solving it from ground of frame. So displacement of A must be equal to D plus displacement of B or not. I hope this thing is clear. No? You can see from the figure only. This blue arrow is of what length? Length same as that of the red arrow, and the separation between them at P equals 0. That is B. So in time t, how much displacement A will undergo? Its velocity is constant. So nothing much to do. Velocity into time. In time t, what is the displacement B will undergo? It will be UDT plus half of AB into T square. But what is the initial velocity of B is 0. So we get VA is V, so VT. D plus half AB is a half AT square. So we'll rearrange and I will write. And what I am going to get is AT square minus 2VT plus 2D equals 0. Up till here, everyone has understood. Nothing much till here, no? Very simple thing it is. All of you understood, no? Till here.
Yes, sir.
Yes, sir. Understood, sir.
Sir,
Mr.
sir, for SP, why do we take that distance formula, sir? Along with acceleration and initial velocity.
Yeah, because his acceleration is constant, no? His acceleration constant, so what formula he will use? His acceleration constant, so displacement of B in time t will be how much? Qt plus half a t square, correct?
So we can then just find this speed and then multiply it with time, no, sir?
So this 1D motion along positive direction, displacement distance, same thing only, no? Suppose if I ask you what is the distance covered by A, you will say SA. What is the displacement of A? What you will say SA. Clear, no? Someone starting from x equals to 0, reaching x equals to 6. What displacement is 6? What is the distance is 6? Clear, no?
Okay, sir.
Okay. So now, after this, what to do, that I will tell you. Tell me if A catches B, if police catches the bike, then you tell me this statement will be true or not. If police catches this bike, then this equation will be true or not. True, no? And if the bike is caught by the police, then this statement must be true. Just want to take
Yes,
this
sir.
call.
Yes, sir.
Call was very important. I'm audible, no?
Yes, sir. Yes, sir.
Okay. Okay, now, so where I was, so if police catches the bike, then this statement must be true. This statement should be true. So if I write down things like this, maybe x is equal to y, then I write x minus y equals 0. Both are same thing or not? If x equals to y is true, then x minus y equals 0 should be also true, correct? This logic, all of you are getting it. So if this is true, then this statement also true, this also true, and this also true. This being true means at square minus 2vt plus 2d must be equal to 0. If it cannot be equal to 0, then the starting statement not true. Starting statement not true means police will not catch the bike. So for police to catch the bike, this box 1 must be true. So this should be also true. So for this quadratic to become 0, it must have some roots which is possible. Correct? And what is the condition for roots of a quadratic to be present or for it to have real roots? There is a math thing. I hope everyone knows that, no man? Correct? if I give you this quadratic for real roots, what is the condition is that discriminant, which is p square minus 4ac, should be more than or equal to 0. Same thing I'll be doing here. B square, which is minus 2v square, minus 4ac, which is 4 into a into 2d, must be more than or equal to 0. So 4v square minus 8ad must be more than or equal to 0. So v must be more than or equal to 2ad. I hope everyone understood this question.
Yes, sir.
Easy only, no? I hope that math part you got it, no? That math part is something you keep in mind. It can be of use in some questions where you get a quadratic and that must be equal to 0. So writing the condition for it to have real roots will give you the answer, the one that you are looking for. Okay, I'll take a new page. Maybe next job is to solve this question by being in the frame of it. So whatever I do, if the final equation comes this, then final answer will come same, no? So maybe I will sit in the frame of it to solve it. I can take a new page. I can take a new page.
Yes, sir.
Yes,
Yes, sir.
sir.
Okay. So let's solve this question just for the sake of understanding purpose, that what kind of thought process you should have and what happens when I sit in one of the frame. You will find final answer will be same. Suppose if I sit in the frame of A, then what I must do? I must consider A to be fixed, no? A will be considered fixed. But what will be doing with B? So to analyze the motion of anything, I must know what all things, the initial position. So I will find initial position of B with respect to A. And what else we need? We need initial velocity. So I will find initial velocity of B with respect to A. And what else we need? Acceleration. So we will find acceleration of B with respect to A. And after that, we will think that B is literally, A is literally a fixed point and B is the only moving point, but moving with this all. This initial position, this initial velocity, and this acceleration, which are relative things. Okay. So 1D motion, our life is easy because in 1D, I can use plus and minus to tell directions. Suppose if I ask you, this is our A and this is B. Velocity of A is constant and it is this side. And acceleration of A is 0. So I'm finding out the velocity and acceleration of each of them from the ground frame. Velocity of B initial 0, but acceleration of B is this side and it is constant. So initial velocity of B 0. Maybe I will consider this direction as positive for our sign convention. And using that as the sign convention, I will write in velocity of A. So what is the acceleration of A is 0. Acceleration of B is plus A. So acceleration of B with respect to A will be acceleration of B minus acceleration of A. So acceleration of B is how much? A. Acceleration of A 0. So answer is plus A. Next thing we will find the initial velocity. So initial velocity of B with respect to A will be initial velocity of B minus initial velocity of A. initial velocity of B 0 and velocity of A always V. So I'll write V. So what we get initial velocity of B with respect to A minus V. Now I'm going to sit in the place of A and literally we will think A not moving and we will provide B with the relative velocity and acceleration. So if A I consider fixed, I'm thinking as if A is the point which is origin itself and B is the only moving particle and it is moving with initial velocity which is this side. No, the acceleration of B with respect to A is plus A means right side and initial velocity of B is how much? Minus V. So what minus really tells us? Minus tells us the velocity of B with respect to A is leftward. What plus tells us? It is rightward, no? So B is starting to move with velocity which is V and that is in the leftward direction. Now, what really the motion of B is from the frame of A? Is it not a motion with retardation? Velocity along minus x, acceleration along plus x. So its speed will be decreasing, decreasing, decreasing. Correct? So only when he will be able to reach A, or suppose if he reaches A. So this is the initial position of B with respect to A. So suppose if I take this as our origin, so this is our x equals to 0. Then what is this point, the name you will give? I took this side as positive, no? So this side will be at point B, the x coordinate you will be giving will be plus t. So B is the only moving particle, A not moving. And if B arrives at the place of A, then I will say A and B are going to meet with each other. If B arrives at the position of A, what is the displacement of B with respect to A will be? So initial position of B with respect to A is plus. And what is the final position of B with respect to A? It will be at A only. So initial position of B with respect to A, if I ask you how much it is, the 1D motion plus and minus will do the job. That will be plus T. Final position of B with respect to A, that is, he is at A, but where A is at origin, so 0. So what is the displacement will be? Final position of B with respect to A minus initial position of B with respect to A. Final position of B with respect to A is 0. Initial position of B with respect to is T. So when B arrives at A, displacement of B with respect to A will be minus T. Now tell me, what is the acceleration of B with respect to A is? Constant or not? Constant. So whenever A relative is constant, never forget. Whatever formulas that are valid for A being constant, same formulas I can use. Just every formula will be having relative terms. S relative will be U relative T plus half A relative into T square. V relative T will be equal to U relative T, sorry, U relative plus A relative into T. V relative square will be equal to U relative square plus twice of A relative into S relative. So here I'm observing it from the frame of whom? A. So everything will be with respect to A with respect to A. So if A arrives at the place of B, sorry, if B arrives at the place of A, I know how much displacement of B will be with respect to A. Since acceleration constant, so I will use these formulas. S equals ut plus half at squared. But you see, every term is a relative term, no? So SBA will be UBAT plus half ABA into T square. How much displacement we undergo? Minus T. What is the initial velocity we have with proper sign convention? Minus V. What is the acceleration we have? Plus A. So AT square. Rearrange and write and check whether we arrive at the same equation that we had earlier or different. So minus 2D equals minus 2VT plus AT square. So write down everything on one side, maybe right hand side, you get AT square minus 2VT plus 2D is equal to 0. Same or different? Let's check. AT square minus 2VT plus 2D is equal to 0. AT square minus 2VT plus 2D is equal to 0. Purpose of solving in this slide is to tell you what kind of mindset you should have when I observe something from the frame of another thing. To solve this question, it was not at all essential that you should solve by being in the frame of A, because solving from ground frame is easy. When solving from ground frame easy only, then why to take any headache? You solve from ground frame. But still, I did the solving from the frame of A just to make my point that, okay, how you should think when I solve something from a frame which is moving. So same equation we arrive at, after that same thing we will do. I'll explain. Which part you want me to explain? This black part or this red part? Okay, I'll explain maybe. Okay. So we are sitting in the frame of A, thinking A fixed. Okay, and providing B with relative things. So where B is at a distance D on the right hand side, and in right hand side direction, I have taken positive. So where B is at t equals to 0 here, what is his initial position is? Yeah, that is what is the point is. We are thinking A fixed, A not moving, man, as if we are solving a brand new question. I told you, no? When you sit in frame of A, you think you're solving a brand new question where A not moving at all and B moving, but moving with relative things. So it is like we are converting a two-body question into one-body question. So what I have to do, I have to find initial velocity of B with respect to A. For that, what I will do, UB minus UA, and I have decided some sign convention this side positive. So what is the initial velocity of B is 0. And what is the initial velocity or velocity of A always is plus V. So what we got, initial velocity of B with respect to A minus V. Minus telling us that velocity of B with respect to A initial will be in the leftward direction. So I gave him leftward velocity V. Now acceleration of B with respect to A will be acceleration of B minus acceleration of A. Acceleration of B plus A. Acceleration of A 0. Correct? So what we got? Plus A. Rate part. See, if acceleration constant, then what all formulas you write? S equals ut plus half at square. Same thing I will write, just S relative will be, if A relative constant, then S relative means relative displacement will be initial relative velocity plus half into relative acceleration into t square. Like for example, I'm sitting in the frame of A observing B. And what I find acceleration of B with respect to A constant. So I'm writing S equals ut plus half at squared. But displacement is the displacement of B with respect to A. Initial velocity is initial velocity of B with respect to A. Acceleration is acceleration of B with respect to A. I hope this is clear. Clear now? So initially, where was B with respect to A? At position. So I'm thinking A is origin and B is lying somewhere on the x-axis, which is on the positive side of the x-axis. In the starting at t0, here lies B. And A remains fixed there, and B only travels and reaches at A. So when it reaches at A where B is finally at origin. So initial position of A plus T, final position of B 0, displacement minus T. Or directly also you can tell B moving in a straight line, how much it has traveled D, which side it has traveled D, left side. Left side D means left side is negative. So displacement is of length D, direction is left side. Left side another name minus, so displacement minus T. Initial velocity with sign convention minus V, so minus. Acceleration of B with respect to A plus A. So A. I got this equation. I wrote this equation, rearranging it. I see same equation, the one we saw from ground frame. Clear to everyone or not? I hope that mindset is getting more clear that what to do when you sit and observe by being in a moving frame. Okay. So once you have done understanding it, tell me to take a new page. So here thumbs up thing also there, no? Yes, there. All of you understood, no? And broadcast quality is better than meet or like same as meet. Main thing is the writing that I'm doing, the handwriting is not going choppy, it is going smooth, no? Things are not like breaking in between. Well, I'm paying for it, man, from my pocket. Just to take your extra classes. I can take through free meet also, but free meet I can't record. And our office is using Joho, and Joho, I tried teaching it once, it doesn't work properly. Please join now. Which part you have joined? When you have joined? Now, like literally now. Or you were there earlier in this slide.
Yes, I joined from this question.
No problem. I am going to share the recording also. If you want, I can explain in 1 second.
Okay,
This
sir.
part, this slide you understood, no? This slide.
Yes, sir.
Okay, then no problem. So we are sitting in the frame of a man. Again, same thing, okay? And we are observing B. So literally, what I think, A fixed, B only moving. But B will be considered moving with relative things. So I have to find his initial relative velocity. So what I do, 1D motion, I use plus minus for directions. So I considered rightward as positive. So initial velocity of B 0, initial velocity of A, which is always same, plus V. So I got initial velocity of B with respect to A as minus V. Minus V means leftward, no? So I'm literally thinking A is fixed and this is our origin, man. And 1D motion, maybe I'll think it is x-axis motion, x0. At t equals to 0, our point B, the only moving point, is present here. And his velocity initial is towards A. And his initial velocity is equal to V. Now next is acceleration of B with respect to A. That will be acceleration of B minus acceleration of A. Write AB, the acceleration of B with proper sign convention, it will be plus A. Acceleration of A 0, we got it as plus A. Plus A means rightward it is. So you consider the moving particle is having an acceleration constant, but in rightward direction. So it has an acceleration a this side. And initially he is present here. At t equals to 0, his position, what position it is? Initial position. So what x coordinate you will give to this position? The initial position is plus t. At time t, he arrives at the place of A because they have to collide. So he arrives at the place of A. So what is the final position of B will be? Origin. But with respect to A, that is 0. So how much is the displacement of B with respect to A? Final position 0, initial position D. So minus T. What is the initial velocity is with sign convention? Initial velocity with sign convention is minus p. What is the acceleration is with sign convention? Plus a. Now, if a constant I can use s equals ut plus half at squares and other equations. Same way, if relative acceleration constant, I can use same those equations just by using every term to be a relative term. I hope that is making sense, no? So here I'm observing from frame of A, then from whose frame I'm writing down the relative things from the frame of A. So I'll write displacement of B with respect to A will be initial velocity of B with respect to A into T plus half the acceleration of B with respect to A into T square. Plug these values, displacement minus T, velocity minus V, acceleration man series. See every class this stupid series at least once it will appear. AT square. So AT square minus 2VT plus 2D equals 0 is the equation we get the quadratic, the one which is same as the one I got it when solving from ground frame. I hope clear, no? Clear or not? After that, what we do, it is same, that quadratic thing, but arriving at the quadratic method different, but answer same, no? I hope understood, no? Sriram, it is, no?
Yes, sir.
Okay, then. Now everyone solve this question. Same way here, we have a box which is starting to move with, but starting to move, so it is told the initial velocity of the box is 0. See, I'm not drawing the figure because my 3D figure who will draw. Let's see whether we can solve it without drawing anything. Acceleration of the box, how much it is given to us? 0.5 units in I cap direction. Now we are throwing a projectile with initial velocity from origin. Initial velocity of from some corner of that box. Suppose that box is your room in which you are sitting right now. Obviously, it's not a round room, maybe. Obviously, if it's fancy house, maybe you might be having round room, who knows? So suppose it is a cuboidal room. So initial velocity of the projectile is this much from ground frame. So I want to solve this question by being in the frame of the box. So I must know the things of the projectile from the box. So what all things I have to know? I have to know the initial position of the projectile with respect to the box. So initial velocity of the projectile with respect to the box will be initial velocity of the projectile from ground frame minus initial velocity of the box, which is 0. So what is the initial velocity of the projectile with respect to the box is this much. What else I need? I need the acceleration of the box What box? Acceleration of the projectile with respect, and that will be the acceleration of the projectile from ground frame minus acceleration of the box. And what is the acceleration of the projectile from ground frame is? It is only going to have an acceleration which is downward, and that is g. What I will use minus j cap to write him down. So that will give us what the acceleration of the projectile is 0.5 I cap. They have told take g as 10. Okay, they have told directly even. No? See, they have given hint also. So it is minus 10 j cap. So acceleration of the box with respect, sorry, acceleration of the projectile with respect to the box will be 0.5 I cap, 10 j cap minus 10 j cap minus 0.5 I cap. Now you are going to solve a brand new question in which box not moving, but a particle moving with this all velocity along x, y, and z, and this much acceleration along x and y. So what to do? Tell me who decides how long a projectile will remain in air? Y component only? Is it not? Maybe I'll try to draw a box. Let's see. Till I'm drawing the photos, you try to solve this question, man. Drawing photos so much difficult here, man. But still I will manage. Suppose if I tell you, take this side as x, take this side as x, this as y, then you tell me this side will be what? Plus z or minus z? I cap cross j cap minus z, no? Minus z, no? Correct?
Sure.
Okay, then. Now tell me, what we have done, we have thrown a projectile with some velocity along y and x. What velocity it has got along y? V2 along y. How much it is having along x? Vx along x. It is thrown with V2 along x and V3 along minus z. So it is going to take some curved path, projectile path only, maybe like this. And maybe it is going to be here.
It's V1 along with X. So
Yeah, V1 along x, yeah, correct. V1 along x, yeah, correct. Tell me who decides how long the projectile will be in air? Y component only, no? Because see this JDX plane, I hope you can see that, is the floor of the room. Okay, JDX plane. So I'm taking a corner in your room where JDX plane is the floor. So particles thrown from origin hitting the floor again. So what is the guaranteed we have it has hit the floor is when displacement along y will be 0, no? Correct or not? So what kind of case it is? particle traveling along y, x, and z all. But whenever it will hit the ground, the displacement along vertical will be zero or not. I hope you can relate it with your room also. Is it background noise is so much or none? Students are talking, man. How many are there? Okay, no problem. So who decides how long the particle stays in air? The vertical things only. So whenever it will hit here, tell me what is the final y coordinate will be. Final y will be 0. And with from what point it is thrown from? Origin. So what is initial y is 0. And when it thrown from O reaches the point, suppose A. So you tell me the range will be OA. But whenever it is at A, it will have some z coordinate, some x coordinate, but no y coordinate. Y coordinate will be 0 only. Correct, no? So tell me when projectile hits the ground, anyone got the answer? Can you find time of flight? I'll give you 1 minute. Everyone try to find time of flight. So for time of flight, we concentrate on vertical components only. So whenever his journey over, whenever he will hit the ground, the displacement along vertical will become 0. The displacement along vertical 0. So we'll find time when displacement along vertical becomes 0. Correct. So I'll write that point. Now you write down, so what we did in projectile motion, we wrote every component separately. The projectile is thrown with initial velocity along x-axis plus v1, initial velocity along y-s plus v2, initial velocity along z-s minus v3. The acceleration along x the projectile has is minus 0.5. The acceleration of the projectile with respect to the box it has minus 10. No, I hope you're getting the point. Literally, I'm thinking box not moving, but projectile moving with respect to the box with some acceleration and some velocities which are relative. So if our projectile is at some point P having coordinate x, y, and z. So tell me what is the initial x, y, and z are? 0, 0, 0. So in time t, how much displacement along x will be? X, because initial x 0. In time t, how much displacement along y will be? Y, because initial y 0. How much displacement along z will be? Z, because initial z 0. No. So if I ask you write the equation of the motion for y direction displacement 1, what you will write? Just a second. Displacement along y will be uyt plus half of ay into t square. So displacement along y in time t will be y only. So y equals how much? Uyt, which is v2. What is ay? Minus of 10 by 2 into t square. So totally we can find out when it is going to hit the ground, y will be 0. So V2t minus 5t square. This is going to give us two roots. One will be 0, correct. At t0, y was 0. Yeah, displacement along vertical, which is y direction, no? Y is vertical here, like the other case. Other root will be V2 by. Okay, I didn't read the question carefully. The stone touches the roof of the box and finally falls on the diagonally opposite point. Diagonally opposite point it falls. Then what is the coordinate of the point L will be? The point A will be. So it has traveled how much along X? L. How much along Y? 0. How much along Z? Minus L. And it is going to touch the roof. So the maximum height it is achieving, they have told us. So what we have to find? V2 value we have to find. Okay. I thought time of flight we have to find. Okay. I didn't read the question. So we have to find, suppose if I ask you what will be the H max. At H max, the velocity along vertical will be 0. So what I will do, Vy square equals Uy square plus twice of Ay into Sy. At maximum height Vy 0, y will be V2 square. Ay is minus 10. Displacement along y is, so height of the room is L. So it will be displacement along y will be L. So what you got V2 to be equal to? V2 to be equal to 20 L. What is L? 5 by 4. So 20 into 5 by 4, what it will be? 5, no? So V2 is equal to 5 meters per second. Okay, then they're asking us how much is going to be V3 and V1. So first job will be to find time of flight. So time of flight, how much it came? V2 by 5. How much V2 is? 5. So 5 by 5, 1 second, no? So time of flight, we got it as 1 second. So the time for which it remains in air, how much displacement it has undergone along X? Initial X, 0, correct? Final X, L. So displacement along X will be, so we have got some acceleration along X, which will be uxt plus half of ax into t square. Displacement along X will be L. Initial velocity along X is V1. Time is 1. Acceleration along X is minus 0.5 by 2 into 1 square. How much is L? We know. So it will be 1 minus 1 by 4. That is 3 by 4. 3 by 4. V minus 1 by 4. L is 5 by 4. 5 by 4 equals V1 minus, see 0.5 is 1 by 4, no? So 0.5 by 2 will be, 0.5 is 1 by 2, no? So 0.5 by 2 will be 1 by 4. So how much V1 is coming out to be? 6 by 4. So 3 by 2 meters per second. Now displacement along Z will be is minus L. And displacement along Z will be velocity along Z into time. So displacement along Z is minus L. Velocity along Z, how much one? Velocity along Z is minus V3. Time is 1 second. So what is V3? V3 is 5 by 4 meters per second. So tell me, easy question or difficult question? Easy only, no? All of you understood? Any doubt anyone is having? Tell me then. Anyone having any doubt? All of you understood this thing or not?
Sir, how displacement along x is 5/4, sir?
Because it is given that it is going to reach the up another corner, diagonally opposite corner. So from you draw the diagonal on the floor and you're reaching this corner. So what is the x coordinate it has? Length of this room is L, no? It's cubical room. Each side is of length L, no? So what is the coordinate of the point A, which is the diagonally opposite point is? L, x coordinate. No? Check out your room. If you go to the opposite corner on the floor, how much you have traveled along x and z? This is minus z. So how much you have traveled along minus z? L. So z coordinate minus L. How much you have traveled along plus x? This side is plus x. So what is the x coordinate? L. Initial x is what? 0 because thrown from origin. Final x is L. So displacement along x, L. Correct? Which is
Sir, but
given.
the box, sir, but the box is also moving, sir. So
Yeah,
when
so no. When we are sitting and observing from the frame of the box not moving. Understood? No. We are solving new question in which box not moving, but particle only moving. See, this question what we did. A not moving, no. B only moving, but moving with relative things. Correct? So same
yes,
thing I'm doing here. I am sitting and observing from the box's frame. So that's why I found all these things. I found initial velocity of the projectile with respect to the box and acceleration of the projectile with respect to the box. And it is thrown from this point, which is the origin, which is in the box. So I know the initial position of the projectile with respect to the box. I know the velocity of the projectile initial with respect to the box, which are this. And acceleration of the projectile from the box is this, which are constant. Not clear, no? Clear or not?
yes,
Easy, no? It became a
yes, sir.
simple question from like ground frame only. So solving this question is like sort of essential to solve it from the boxes frame, no? Correct?
Yes, sir.
Okay then. So
Yes, sir.
if anyone having any trouble, tell me. So you see that no, to discuss some question properly in depth, how much time really it requires, no? Correct? That's why I have to take extra class. So you see, I can give homework, but if you're not solving it, there's no point of giving the homework. So that's why you should try at least what to do 1 minute, 2 minutes at least. Then if I discuss it, then only you will become good in the subject. Even this question done, still you solve it on your own again, maybe. Okay, even though it may feel
Sir, but
boring, but please tell me.
sir, but the velocities V1, V2, and V3 are given with respect to the Earth, no, sir. But how
Yeah.
can you
So
use it?
I found it out. No, initial velocity of the projectile, where you were when I was talking about this. Initial velocity of the projectile with respect to the box will be what? We'll zoom it a little bit, just a moment.
Okay.
Okay, no, initial velocity of the projectile minus the box. But box initial velocity is 0, so life easy, no? Understood?
Yes. Yes,
Easy,
sir.
easy, no? All of you understood, no? Man? All of you understood? No, if not, you tell me. I'll explain again.
Sir, I don't understand how like I travels at constant velocity in the z direction.
So, because in jet, what is the acceleration of the projectile with respect to the boxes? It has x component, y component, but no z component. So, acceleration along z is 0, which I did not wrote here. Understood? No. Because what is the velocity of acceleration of the projectile has got minus 0.5 I cap, no, and minus 10 J cap. I don't see any Z component. So 0. Clear, no?
Yes, sir.
Other part you understood? So if still some confusion lingers, then you think about it after the class also. Don't expect that something discussed straight away you will understand. No, may not be. Then only class is good. Everything you understand straight away means, man, I'm teaching easy things. G things will take time. Okay. Once done understanding, or in case you're copying, done copying, tell me, I will take a new page. Samsung guy crying, man. What happened? Your correct name not saying. Okay. Anyone having any doubt? All of you understood, no?
Yes, sir.
That's what understood. Good. Okay, then we'll discuss some other question then. In this much time, how much we have discussed? Nothing, man. Nothing. Okay. We will do some riverboat questions. Which box I have or not? Student, I have in my WhatsApp. Give me 1 second. One student shared me the PDF of these things. Very good thing as well. Okay, open the binder box, the riverboat one. Near the riverboat, all of you understood? Any confusion? If you have, I can discuss, not an issue. So let's solve binder box 2. Here, question number 2. This app I cannot paste anything. If I paste, it crashes me. In this app also I bought it to teach me, not free app. So a man is crossing a river flowing with velocity 5. He reaches a point directly opposite across a distance of 60 meters in 5 seconds. So what it is told? He reaches directly opposite side of the bank. So he is reaching the opposite side of the bank, means he is undergoing zero drift, or he travels without any drift. You want to try, or I should solve it? That zero drift case, all of you have understood, no? Anyone having any confusion, ask. Don't be under peer pressure that other people told you they have understood. How come I will say I have not understood? Don't think like that. It's your marks, your rank, your life. Don't think about what others are thinking. Others are stupid people. Don't worry about them because they are already worried about what you are thinking about them. The velocity of the boat with respect to the river may be supposed like this. So you see, I'm not using any formulas because that is not good. I'll be deriving those formulas again and again whenever I need such things to be solved. Velocity of the river VR. Now, if I ask you find the velocity of the boat with respect to the ground frame, what is the what every time these questions will be having this purpose only. Find VB vector by adding VBR vector and VR vector. And this angle, let's call it as alpha. So what is the velocity of the boat with respect to the river? Maybe I ask you, consider this as our y, this as our x. So velocity of the boat with respect to the river has got one component along minus x, and that will be minus v sine alpha. Other component is v cos alpha j cap. Velocity of the river is u I cap. Adding them, what we get is u minus v sine alpha I cap plus v cos alpha j cap, correct? The moment you get VB, no man, then it becomes like a new question, which is an easy question. Suppose if I tell you, so see, simultaneously I'll be using parallelogram law also to justify or to apply some logical reasoning. If this is our VB vector, VBR vector, and this is our VR vector, then sum of these two must be passing somewhere in between them. Maybe this is our VB vector. Now they are telling us that we are reaching the opposite side of the bank. So he starts from here and reaches here. So from ground frame, I see him reaching the point P. It means the velocity of the boat with respect to the ground frame will be in that direction. So this vector is lying only along y, no? It means his x component should be 0. That is the condition of zero drift. So once I tell you VB, then what you think? You think I have a particle which is moving or maybe walking on the ground with this much velocity along x, which is constant, and it is moving with this much velocity along y, which is constant. Then I want him to travel with constant velocity, but I want him to have zero displacement along x. Then when it is possible, only when velocity must be zero, no? You're not supposed to change the velocity along x direction, and I want to travel nothing along x. Then velocity along x must be 0. So what we will get here is sine alpha must be equal to u by v. So one thing I can write next. If I travel like that, if sine alpha is equal to u by v, then what vb will be? It will be v cos alpha j cap. So velocity along x0, only velocity it has is v cos alpha. Got the point? Know what I've done here? I have replaced sine alpha with u by v. Vb has got no x component. It has only y component, which is v cos alpha. So when river crossed, how much displacement we will see along the direction, which is y? When river is crossed, displacement along y will be equal to river's width. And what is the width of the river is? Suppose I call it as b. So displacement along y will be equal to velocity along y into time t, because we don't have any acceleration along y. Displacement along y b, velocity along y v cos alpha. So time to cross the river, we know that will be b by v cos alpha. Okay. Now let's see what all things are given. So he crosses the river. What is the width of the river they have given us? 60 meters. What is the speed of the river given to us? As so it is given that u is equal to 5, and then so this thing is confusing you, I must tell you. Velocity of him in still water, which means if it is told a man can swim in still water with a speed 5 meters per second, or a man can swim in a still water with a speed of 10 meters per second, which means even in running water, his speed with respect to the water will be same. So they're asking us to find the speed of the man that it will be if he swims in the still water, is a way of telling find out the value of the speed of the boat with respect to the river, or find out the value of speed of the swimmer with respect to the river. Okay, here is swimmer, so boat or swimmer. Technically, from kinematic doesn't make any difference. So what they're asking us to find the value of the v. So we have made two equations. One is sine alpha is equal to u by v. So sine alpha given, I can find cos alpha. No, cos alpha will be root over 1 minus sine square alpha. So that will be 1 minus u square by v square root over, that will be v square minus u square root over pi v. So time to cross the river is b by v cos alpha. So b by v into root over v square minus u square by v. V gone. So t equals b by root over v square minus u square. So in this equation, t I know, b I know, u I know, v I have to find. So t is equal to 5 seconds. B is equal to 60 meters. V I don't know. U is equal to 5 only. So 5 square. So we get, solve this thing everyone from here. So we get V square minus 5 square, which is 25 root over to be equal to 16 by 60 by 5, 12. No? So V square minus 25 is equal to 144. And this is like famous thing that V square equals 144 plus 25, that is 169. So what is V is equal to root over 169. And what is that? 13. Clear, no? I hope all of you understood this thing. I hope all of you understood this thing, no?
Yes, sir.
Yeah, then let's try question number 6. The boat sent perpendicular to the river with velocity 8 km per hour. If the resultant velocity of the boat is 10, then find the river flow velocity. So easy question only, just language it is. So while I draw the figure, you try to solve it, everyone. Anyone got the answer?
Sir, is it 6?
Yeah.
Okay.
So what is given is the velocity of the river is this side, and that is given to us. And the boat is sent perpendicular to the river flow, means the velocity of the boat with respect to the river is like this, and that is not given to us. But the resultant of this flow is given to us, VB given to us. So VB will be somewhat like this. And VB equals VR plus VBR, correct? What is VR? It is U I cap. What is VBR? That is V J cap. So VV vector has two components, U and V. So what VV vector length is? Root over U square plus V square. So easy question only. We are told that root over U square plus V square is equal to 10. So U square plus V square is equal to 100. So V I have to find. So V square is equal to 100 minus U square, which is 8 square. So V square is 36. So V is equal to 6. Nothing much in this question. Ruchi got it, no?
Yes, sir.
Next, exercise 1. Question number 3 and 4 we will solve. Maybe 2, 3, 4, all three we will solve. Everyone solve fast. You have the module with you also, no? Exercise 1, question number 2. Solve fast, everyone. The boat is moving with velocity 3 I cap plus 4 j cap with respect to the ground. The water is flowing with a velocity minus 3 I cap minus 4 j cap with respect to the ground. So velocity of the boat with respect to the water. They're asking a simple thing. Nothing much to do. So velocity of the boat is 3 I cap plus 4 j cap. Velocity of the river is minus 3 I cap minus 4 j cap. So velocity of the boat with respect to the river will be velocity of the boat minus velocity of the river. So that will give you 6 I cap plus 8 j cap. So nothing much in this question. Okay. Next question I can go to. Okay, you may be tired also, no?
Yes, sir.
Okay then. So please try to do the question that I gave as homework in the class. Go through all the riverboat questions. I'm not expecting that you will be able to solve most of it. But that is not the purpose. Purpose is you should try. So please try all the riverboat questions and questions of finding minimum separation between moving particles. Whatever questions I wrote as homework last class, please try all. We'll discuss in the class. And those who was absent in the relative motion class, I forgot her name. Okay, some people left the class also. Okay, then we'll end the class now. In case if anyone in need of some doubt or anything, I can send a link at 6. You join through that. We will discuss doubts from 6 to 7. Okay. I will send live recording, but maybe I can't send it now because it takes some time to process the recording. First time I'm using Zoom. I don't have any idea how long it will come back. Once it comes, I will send it as soon as possible. This PDF I will send, no problem. Okay then. Bye everyone. Thank you for coming in the extra class.
So thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir.
Bye, sir.
Bye bye. Okay, I will end the meeting. I'm going to share all this as PDF. Yeah.